a lot of the research I've done into Dassault, they always talk about this quote unquote connection to the real world and so forth. And one of the terms that I read a lot on in various Dassault materials is this concept of the virtual twin.
Mm-hmm.
So obviously we do not necessarily have a lot of time, but if you could give us a brief rundown as to this virtual twin concept.
Mm-hmm. Yeah, as I said, the start of my career was working and building digital models of mainly manufacturing operations. So we had programming style languages which allowed us to code a model of a shoe packaging line, or a fast food restaurant, or a manufacturing operation. And it was we developed this model where you could simulate what would happen. But those models were very much sort of offline. It took a long time to build them. We fed them with probabilistic and stochastic information to see what might happen in the real world, and then we would run it for a day, a day in real time, simulating perhaps a year of simulated time, and then operations people would use that to make better decisions about how to lay out their line, or how to do it. That was the birth of digital twins, and they were sort of static, offline. They were fed with statistical data versus real world data. So if you think now about today's version of that, which we call virtual twins, or the virtual twin experience, it's largely trying to solve the same problems. I mean, we're trying to make mistakes in the virtual world so we don't make them in costly and expensive or unsafe ways in the real world. So it's the same concept of building a model of our product or our operations or our supply chain. But the difference is now we're not building it in a programming language. We are taking objects of robotic arms, or machining centers, or test and assembly operations, or whatever that might be, and we're dropping them into a model. And those objects are rich with not just a visual representation of those operations, but all of the details of the speed and the flow rate and the preventative maintenance and all the rest of it. So we're building it from an object-based point of view, and we're connecting it with real-time data. So if we build a virtual twin model of let's say a packaging line, as we go through and we collect information about what's happening, we can feed that information back into the virtual model, so then we can refine it, make changes to it, see how we can do things better, see how we can react or reconfigure the line based upon more breakdowns than we expected, or supplier changes or material changes. And so the difference is between the digital twins of the early stages, which was part of my legacy, and the virtual twin of today, is that virtual twin model is something which sort of lives and breathes. It's actually connected. It's being informed by the real world. You can make changes to it. It's modular. It's reusable. So once you've built the model of your production line and made your decision about perhaps a line layout change, you don't throw it away. It continues to live and breathe as a working virtual model of that environment. You can continue to make changes to it, and more importantly, you can connect it to other parts of upstream and downstream processes. So if you are doing, if you have a digital thread from design and engineering, so if you have your CAD models of your products, that model-based information persists, and then you can use that as part of the virtual twin of your manufacturing operations to determine, if I make a design change, what does that mean to the engineering bill of materials? What does that mean to the manufacturing bill of materials? And therefore, how will my model respond to that if we change part A to part B, or if we make a modification or a design change? So dramatically different from what previously were called digital twins. What we see as a virtual twin is something which is in constant use, and something that can be used very easily and rapidly for lots of different types of innovation, or reacting to disruption, which is of course flavor of the day for most manufacturing companies.
During your last answer, you talked a lot about making changes in real time. And just out of curiosity, because it seems to me that the flavor of the day these days is Industry 4.0. So out of curiosity, is Delmia making changes or adapting this virtual twin concept in a way that benefits Industry 4.0? And if so, how?
Yeah, I think virtual twin technology is very much a core part of Industry 4.0. There are lots of different elements of technology and connectivity, IoT connectivity between what's happening on the shop floor and analytics and data sciences. That's all part and parcel of Industry 4.0. I think we've been an enabler of key parts of that technology for a long time. We're constantly adding to it, and so think about other new technology in Industry 4.0, like augmented reality as part of the new workforce of the future. We have capabilities we've added to our portfolio products that support that as well. And so it's all part and parcel of that. Whether you call it Industry 4.0, smart factory, there's a lot of different terminology. I think it's sometimes confusing to manufacturers as to what do we do or where do we do. What do we do first in terms of getting that next level of digitalization of the factory or reaching some of those Industry 4.0 standards? But yeah, we've been strong proponents of supporting that and other areas for quite a while now.